Alright, here's a warm-up on evaluating some logarithms. You may want to, before you really start into the lesson, see how many of these you can do on your own. Ideally, you can do them all on your own right now. We're getting ready to take a quiz after this section. So take a look at these and we'll discuss them. We should be able to do each of these without a calculator. Log base 2 of 16, that means 2 to what power equals 16? And 2 to the 4th power equals 16. Ln for natural logarithms, a log base e. So you think the log base e of e squared. E raised to what power would give you e squared? And that would be 2. Remember that your ln and your e are inverses, they're opposites of each other, they'll cancel each other out. So ln of e to the second is just 2. Ln of 1 over e to the 3rd power, we can use that property that ln and e cancel out if we can write this as e just raised to a power instead of a fraction. Remember what takes things to denominators? Negative exponents. So ln of e to the negative 3rd power, that'll cancel out, give you negative 3. And finally here, ln of a root expression. To rewrite a root expression, the root that you have, this is a 4th root, that goes in the denominator of your exponent. This power here goes in the numerator of your exponent. The 4th root of e to the 7th is like e to the 7/4 power. So the ln of e to the 7/4 power would be 7/4. Right? So quick reminder of how we evaluate logarithms without a calculator there. The main goal of today is to talk about the different properties of logarithms and how we can combine logarithms to simplify, or sometimes how we can evaluate some logs or rewrite some logs that we wouldn't be able to do by hand. Log base 2 of 37. 37 is not a power of 2. I can't say 2 to some power gives me 37. 2 to the 5th is 32, and 2 to the 6th jumps past that. So we can get an exact value for this without a calculator. What we can do is evaluate this in the calculator, write this in a different way using what's called the change of base formula. Now for some of you, this formula might not be that important. If you have an older graphing calculator, or even some of the newer yellow ones, that log button only does the common log, the log base 10, not the log base 2. So in order to evaluate this with the calculator, we need this change of base formula. The change of base formula says this. If you're trying to evaluate a logarithm, I'll just say base b down here, and I'll call that an a. Call that a because we call the number in the log an argument, so it's argument in the base. We can rewrite that, changing the base into a base that we're comfortable with. There's really 2 buttons on your calculator that will help us here, the log button and the ln button. We can use either one. The change of base formula says the log base b of a is equal to the log of b, rewind, pause, log of a over the log of b. It's the log of the argument over the log of your base. Or you can do it as the natural log of the argument over the natural log of your base. All right? So change of base. If I want to do the log base 2 of 37, I can do that in my calculator by making this log of 37 divided by log of 2. Or the ln of 37 divided by the ln of 2. And then I got to type that into my calculator. I've got log 37, parentheses, divided by log 2, parentheses, 5.209 for my decimal. And a little bit more than 5 is kind of what I expected there. Now, if you've got a newer calculator in your math menu there, if you scroll down, you may have a log base function where you can actually type in log base 2 of 37 and get you that. So kind of mess around with that. Different calculators will have different results there. we can always use the change of base formula to get this exact answer, right? So that's one of the properties of logarithms that's important to know. You might see that on the ACT. They might ask you to rewrite a log function in this way. So log of the argument over log of the base, whether it's common log or natural log. All right. Now the three major properties of logarithms I'm going to take you through now. How can we combine logarithmic expressions and simplify logarithmic expressions? First property, if I'm adding two logarithms that have the same base, the key here is the bases have to be the same. If the bases are different, you can't combine them. It'd be like saying x squared times y cubed. You can't combine those because there's an x and there's a y. If there are different bases, we can't combine. But here, since the bases are the same, the property is, if you're adding two logarithms, you can combine these into a single logarithm by multiplying the arguments together. So multiply the arguments. You can combine two logs that you're subtracting into one log, provided it's the same base, by dividing the arguments. Right? So if you're adding logs, you can multiply the arguments. If you're subtracting logs, you can divide the arguments. This is the reverse of properties of exponents. Remember that logs are inverses of exponential functions. And when we had, let's say you were doing x to the fifth times x to the third. You could add those exponents and be x to the eighth. Right? So if you're multiplying exponential expressions, you can add the exponents. This is the reverse of that. If you're adding log expressions, you can multiply the arguments. Same for here. If you said x to the fifth divided by x to the third, you could subtract exponents. Now if you're subtracting logs, you divide the arguments. So it's the reverse property. And then the third one here, if I've got some number in that I'm multiplying by the logarithm, I can take that coefficient there and it can come up and become an exponent in the argument. This can become the log base b of x to the n power. So there's your three major properties. Adding logs, you multiply the arguments. Subtracting logs, you divide the arguments. If you've got a coefficient of your log, that coefficient can become an exponent for your argument. Right? Make sure you've got those jotted down somewhere. I've got lots of examples that I want to do with you here using these properties to combine logarithmic expressions. All right. Here are several to get us started. I have the log base 2 of 5 plus the log base 2 of 7. The bases are the same, so I can keep that same base and multiply the arguments. So now that log expression is just a single log. Log base 3 of 48 minus log base 3 of 2. Same log, same base. Divide my arguments, 48 over 2. And there you go. Last one here. Same base each time, base 10, your common logarithm. Now I've got a coefficient. You want to take care of those coefficients first. So log 2 log 3, make that 2 an exponent. Turn this into the log of 3 squared. Then you've got plus the log of 20. Minus the log of 2. Now we can condense all this down into one log. Log base 10. We're multiplying those arguments. We're dividing that argument, and then we'll simplify that. So that's 180 over 2 log of 90. We can simplify that all the way down there. All right, take care of that coefficient first, and then we can combine. Notice the difference between this and the change of base formula. We're condensing this into one log. It's just a log of a single number. Back when we did that property of the change of base formula, that was two different logs being divided. Log A over log B at the end. This was not log of 37 over 2. It was log 37 over log 2. Here, it's just the log of 48 over 2, condensing it into one logarithm. Right? You can do this with variable expressions as well. Like so. Did a natural log this time. Again, same base, base E all the way through. So let's take care of the coefficients first. 3 ln x can be the ln of x cubed. This can be the ln of y to the fourth. This can be the ln of z to the 1/2. Now, adding these two logs together, multiply the arguments, subtracting this log, divide that argument. So your expression might look like this. A lot of times you won't want to see fractional exponents in your final answers. So if you're maybe seeing this as a multiple choice question, instead of calling this z to the 1/2, what's another way we could write z to the 1/2 power? 1/2 power is like taking a square root of z. So you're more likely to see an answer written this way in a multiple choice setting, getting rid of fractional exponents. Same with negative exponents. Right? So those are your properties of logarithms, and we will practice those in class tomorrow.